Imagine descending into an endless abyss, where the last rays of sunlight fade into total darkness. Just as you think nothing could survive here, the ocean comes alive. Tiny sparks, glowing tendrils, and pulsating orbs begin to light up the darkness, like stars in the night sky. This is bioluminescence, a breathtaking phenomenon where life itself becomes the light. But why do these creatures glow? Are they signaling to others, luring prey, or hiding in plain sight? The answers are more mysterious than the lights themselves. Bioluminescence is nature's chemistry experiment perfected over millions of years. At its core, it's a chemical reaction where luciferin, a light-emitting molecule, interacts with oxygen and enzymes to produce light. But here's what's fascinating. This isn't just a random occurrence. Over 75% of deep-sea organisms use this light in some way, making it one of the most widespread survival strategies on Earth. But how can a process so complex exist in creatures as simple as plankton? And what does this tell us about evolution in the deep sea? In the deep ocean, where darkness is absolute, communication is nearly impossible. Yet bioluminescence allows creatures to talk to one another in ways we're only beginning to understand. Some fish flash intricate light patterns to attract mates. Others, like the flashlight fish, use glowing organs to navigate and signal their shoals. But here's the twist. This light can also be a deadly lure. For predators like the anglerfish, glowing bait becomes a trap, enticing prey right into their jaws. Is bioluminescence a beacon of life or a harbinger of doom? In the deep sea, being seen often means being eaten. To survive, some creatures use bioluminescence to disappear. This phenomenon, called counterlumination, allows them to match the faint light filtering from above. By lighting up their undersides, they blend perfectly with the water column, becoming invisible to predators below. It's an extraordinary trick of survival. But could there be creatures that take camouflage even further, ones we haven't even discovered yet? Bioluminescence isn't always subtle. Sometimes it's a weapon. The vampire squid, for instance, ejects a cloud of glowing mucus to startle predators and escape. The Atala jellyfish takes it to another level, using a burglar alarm technique, flashing intensely to attract even larger predators to its attacker. These creatures have turned light into a survival tool, capable of both defense and deception. But how do they decide when to use it? And how do these displays affect the fragile balance of life in the deep sea? Some predators have taken bioluminescence to terrifying extremes. The dragonfish, for example, uses red bioluminescent lights, rare in the ocean, to see prey that remains invisible to others. With a glowing lure and teeth sharper than needles, it's a predator designed to dominate the abyss. But how did such a creature evolve? Could there be even more advanced predators hiding in the unexplored depths of our oceans, using light in ways we can't yet comprehend? Bioluminescence isn't confined to the deep ocean. In shallow waters, glowing plankton create magical light shows, lighting up waves, shorelines, and even footprints in wet sand. These displays remind us that bioluminescence isn't just about survival. It's also a phenomenon that bridges the gap between the alien world of the ocean and our everyday lives. Could studying this light show unlock secrets about our planet, or even inspire innovations in science and technology? Bioluminescence is more than a natural marvel. It's a field of endless possibilities. Scientists are now studying how these creatures produce light to develop bioluminescent streetlights, sustainable energy solutions, and even medical breakthroughs. But as we uncover the secrets of this glowing phenomenon, we must remember the fragile ecosystems that produce it. Will humanity find a way to protect these luminous wonders, or will the light of the deep sea be extinguished forever?